All right, the formula for that fourth moment. What we're going to do is we're going to take those deviations, but instead of squaring them, we are going to take them to the fourth power, the quartic of the deviations from the mean. From there, we're going to multiply by the probabilities, just like we've done in the past, and then we're going to add, just like we did in the past. In terms of calculating our kurtosis, there's this kind of little wrinkle where what we do is we divide by the standard deviation to the fourth power. Remember, when it came to the standard deviation, what we did is we took the variance and then we took the square root of the variance at the end. Well, this is kind of that same version of that. We don't take the square root, we divide this sum by the fourth power of the standard deviation. Great, let's head in. First step is that we're going to calculate the individual deviations. So we're going to say, I want to know policy profit, each and every individual scenario, minus the expected profit, which in this case is that 1720. I'm going to kind of put this like so, and Google Sheets suggests an autofill. Then I'm going to take the fourth power equals this to the fourth power, and I get this huge number. Just kind of to show you what's going on here, I am going to take this value over here and multiply it by its probability of occurrence. And from there, I am just going to drag down. And that's what I want you to do. And this is your probability weighted quartic loss, your probability weighted quartic break even, and your quartic gain for the total quartic sum, kind of the quartic version of variance, as you will. And then to calculate the kurtosis, remember, you have to divide by the fourth power of the standard deviation. So what you're looking at here, we have our standard deviation, and we're taking that standard deviation to the fourth power and dividing through for a kurtosis of 41.27. Now, just as a quick word, because I did this kind of piece, this is not excess kurtosis. Like if you had just calculated excess kurtosis somehow with with an actual data set that you had in Google Sheets or in Excel. So the kurtosis is huge, but we expect it to be huge. I mean, this is a crazy distribution where we have like this really big, nasty negative outcome and a fairly decent chance that that's what's going to happen. So we'll do a little bit of cleaning here, and what your job is to just kind of repeat what I did after you've had a chance to play around with the events themselves and modify them as you see fit and change up their probabilities as you see fit. So have at it.